Continuation of the last video. So here double derivative we are applying for the function f of x. So f double dash of x is equal minus 1 by sigma square x minus mu into f dash of x plus f of x. Okay, so this is here we applied uv formula, right? So this is u as this, and the derivative of v is nothing but v dash plus v is nothing but f of x and u dash. So the derivative of this one. So x derivative is 1 and mu is a constant. The derivative of mu is 0. So 1 minus 0 is nothing but 1. So 1 into f of x, f of x. So for that we wrote x minus mu into f dash of x plus f of x, which is equal minus 1 by sigma square. We are writing as this. We are not doing any change in that. And next x minus mu as this. And in next f dash of x, already we calculated this one, that f dash of x we are substituting here. So minus of x minus mu by sigma square into f of x plus f of x we are writing as this. So here we didn't change anything in the above step. We wrote this one as this. Simply we substituted in place of f dash of x as this total one what we calculated in previous one. And now if you observe this one, so in this, and this is entire one term and this is another term. If you observe in that, so which one is the common one? Here f of x and here also f of x. So in both the terms f of x is the common one. So for that, so we are taking f of x as common one. So for that, simply we are writing outside of that. And what about remaining? Here it is. So x minus mu and here x minus mu. So a into a is nothing but simply what we can write. So a into a is a square. In the same way, there it is x minus mu into x minus mu. So x minus mu into x minus mu means x minus mu whole square, minus we are writing as this by sigma square. And next we took f of x as common one. So what about remaining? Plus 1. So keep in mind, whenever if you are taking common any term, if you multiply the term instead of the terms, you have to get the above step as this. So for that we are getting as this or not. So after multiplying this one instead of the term, we are getting again same as this. So this is double derivative of f. So f double dash of x is equal to this one. Now we need to check the value of x in play. X is equal to mu. So at the point x is equal to mu, we are substituting in place of x as mu. See here it is. F double dash of x is equal minus f of x by sigma square at x is equal to mu. Why here it is? What about remaining term? So what happened here? If you substitute in place of x as mu, what will get? Here it is mu minus mu, right? So mu minus mu whole square. Okay, so here it is mu both will cancel. It means what will get? 0. So 0 by anything? 0. So 1 plus 0 is nothing but 1. So 1 into this one will get only this term minus f of x by sigma square. So for that here we wrote minus f of x by sigma square at x is equal to mu. And now here it is 1 by sigma square as this. And what about how we got this one? 1 by root 2 pi into 1 by sigma. Why? Because already we know that f of x. So by the definition of normal distribution we are using. If you substitute in place of x as mu. So what about f of x here we chosen? So this is f of x we chosen 1 by sigma by root 2 pi e power minus 1 by 2 x minus mu whole square, right? If you substitute in place of x as mu, what we'll get? Mu minus mu is nothing but 0. So what we'll get here is e power minus 0 or simply e power 0. Anything power 0 is always equal to 1. So 1 into this total value you are getting as 1 by substituting in place of x as mu. Now what about remaining? Only this is the remaining term, 1 by sigma into square root of 2 pi. So that's why there we wrote here it is 1 by sigma into square root of 2 pi into 1 by sigma square. So 1 by sigma square as it is 1 by sigma into root 2 pi. And now here it is 1 by sigma cube into square root of 2 pi. Minus is here. So if you take any value in place of sigma, so sigma is nothing but here it is standard deviation, and standard deviation always must be greater than 0. So for that, if you substitute any value in place of sigma, we'll get it as minus value. It means it represents the entire value, will get it as negative 1. So that is symbolically we are writing as it is less than 0. So what we are saying at mod is nothing but at which value of x the function f of x has maximum, then we are saying that is the mod, right? So here it is at x is equal to mu, we are calculating that. So there we got it as f dash double dash of x is less than 0. For that we can say that x is equal to mu is the mode of the normal distribution. Okay. If you observe the next, here it is x is equal to mu and mean also we got it as mu, and next we are going to calculate median. So median of the normal distribution. So this is already we got it in continuous one. So what we are saying, median is nothing but it divides the entire one into two equal parts. So for that, here it is, if m is the median of the normal distribution, then we have integral minus infinity to m. Actually what we wrote there, the formula minus infinity to m f of x dx is equal minus infinity to m f of x dx is equal integral m to infinity f of x dx is equal. So integral m to infinity f of x dx is equal 1 by 2. So this one we said there what we discussed in continuous. So it divides the entire distribution into two equal parts. At which point that is dividing, that one we are calling as a median. So for that, integral minus infinity f of x dx is equal integral into infinity f of x dx is equal 1 by 2. So here I chosen first one and this one for calculating median m. Okay, and by the definition of normal distribution, what we know that f of x is equal 1 by sigma into square root of 2 pi e power minus 1 by x minus mu by sigma whole square dx. So just here we used normal distribution form. So f of x is nothing but simply we substituted here. And now here it is. Now we are going to simplify this. So already we know that median is on mean. So by using that, so here we are dividing that one into two parts. So one is 1 by sigma into square root of 2 pi integral minus infinity to mu e power minus 1 by 2 x minus mu by sigma whole square dx plus mu to m e power minus 1 by x minus mu by sigma whole square dx is equal 1 by 2. So and we are giving name as this is equation 1. Okay, now we are taking this part. So consider 1 by sigma into integral minus infinity to mu e power minus 1 by 2 x minus mu by sigma whole square dx. So this one we are choosing. Now same simplification how we solved in previous one, same like that. First, we are taking assumption here, put x minus mu by sigma is equal to t. And next, x minus mu we keep it. So cross multiply on both sides. Here it is having x minus mu as one term and by 1 here it is. So x minus mu into 1 is x minus mu sigma t. And next, x is equal, just we are taking that mu into right side, mu plus sigma t. And next differentiating on both sides with respect to t. So that is actually will get as with respect to t means dx by dt is equal, the mu is a constant one, the derivative of constant is 0. So this is 0 plus sigma into d by dt of t is nothing but we'll get it as 1. So this is we'll get it as after applying derivative with respect to t. It means what we got it there, dx by dt is equal. So dx by dt is equal to, here it is sigma. Then simply we can write this one, cross multiply that, dx is equal by cross multiplying that sigma into dt. Okay, so this one we wrote directly here, dx is equal sigma dt. Okay, so dx, it means what we are doing here, we are converting the entire variable in terms of x into in terms of t. Another variable we are converting now. So now we are going to simplify, we are substituting in that. So this is a definite integral. So for that we are going to substitute the limits. So these are the limits of x. but we require the limits of t. So t limits we require. So for that, when x is equal to minus infinity, what about t? So if you substitute in place of x as minus infinity here, minus infinity is by anything is minus infinity. So for that t is equal minus infinity as it is. And next, what about another limit? So mu, when x is equal to mu, what about t limit? So if we substitute in place of x as mu, what we'll get here, it is mu minus mu by sigma. So mu mu cancel, so it means 0 by sigma is 0. It means when x is equal to mu, what about t? So t is equal to 0. Okay, so these are the limits of x and t. Okay, so x limits are from minus infinity to mu, and t limits are from minus infinity to 0. Okay, now we are going to substitute all those things in that what we chose in the assumption. So 1 by sigma into square root of 2 pi. So here we got the limits minus infinity to 0 e power, we already chosen x minus mu by sigma is t. So here it is, we are substituting in place of this one as t. So t square by 2, and dx is nothing but what we got it, sigma dt. Now we are going to simplify this one. So here it is, sigma by sigma square root of 2 pi. Here it is, already we have sigma. So why? Because inside we wrote it as sigma into dx is equal, sorry, dx is equal to sigma dt we substituted. So there it is, sigma is a constant, so for that we are writing outside. After writing outside, sigma sigma both will cancel, 1 by square root of 2 pi integral minus z square by 2 dz. Here it is having t in terms of t we have, so we write it as z in terms of normal distribution. Generally we call it z distribution also. This is not a mandatory. If you want, you can change, or we may not change. And next, due to symmetry. So due to symmetry, in the sense, in normal distribution, what we are saying, how much distance from 0 to left side, same that much of distance from 0 to right side. Or in another words, we can say that we can interchange the, this is a even function, and simply we can write that one also. Okay, so integral 0 to infinity, it means here we are discussing normal distribution. So normal distribution is symmetrical about the mean, x is equal to mu, so symmetrical about the mean, and z is equal to 0. It means how much distance from this to this, minus infinity to 0, same 0 to infinity. Okay, why? Because the total area under the curve is 1. So for that, here it is due to symmetry, we are changing that 0 to infinity e power minus z square by 2 dz. Okay, now we are going to simplify this one. 1 by square root of 2 pi. So this value we can get it. So directly this value already we proved previously. Integral 0 to infinity e power minus z square by 2 is nothing but root pi by 2. So here it is root pi and root pi both will cancel, and root 2 into root 2 is nothing but 1 by 2. Okay, so let me take it as this equation 2. Now from equation 1 and 2, so what we can write there? So here it is, from equation 1 and 2, simply 1 by 2 is substituted. What we got it here, it is, this is equation 1. So in that first value, first one we simplified. First one what we got it here, 1 by 2. So for that we substituted 1 by 2 plus integral mu to m 1 by sigma into square root of 2 pi e power minus 1 by 2 x minus mu by sigma whole square dx is equal 1 by 2. If you see these two, so here it is, 1 by 2 and 1 by 2 both will cancel. And what about remaining? This total value integral m into m 1 by this one is equal 0. Then integral, we have indefinite integral one property. If it is integral a to b f of x dx is equal to 0. So integral a to b f of x dx is equal to 0. Then simply we write, then a is equal b, a is equal b. So this one simply we wrote here, mu is equal m. Okay, so mean mu is equal m, we got it. So median is also we got it as mu. Okay, now why you taking this? If you observe that mean we got it as that one, and variance also not variance, median we got it the same one, and mode also we got the same one. So in some of the cases they may also show that prove that mean is equal to mode is equal median. Okay, so for that hence the distribution is symmetrical. So when we say that symmetrical, in first unit we already got it. Symmetrical is nothing but when the mean value is equal to 0. Okay, then we say that that is symmetrical. Okay, next. Next one, mean deviation from the normal distribution. So mean deviation from the mean deviation from the mean for normal distribution. Okay, so by the definition of mean deviation about mean is, this is a formula we use in continuous random variables. Okay, in first unit, integral minus infinity to infinity mod x minus mu f of x dx. So here f of x is nothing but normal distribution. We are substituting here 1 by sigma into square root of 2 pi e power minus 1 by 2 x minus mu by sigma whole square. This is f of x. Now we are going to simplify that. Put x minus mu by sigma is equal to t. X minus mu is equal to sigma t. Then what we get? X is equal to mu plus sigma t. So x is equal to mu plus sigma t. And next to limits, there is no change in that. Why? Because if we take minus infinity, we get minus infinity. If we take plus infinity, plus infinity, then what we'll get? So 1 by sigma into square root of 2 pi as is. So 1 by sigma into square root of 2 pi integral minus infinity to plus infinity mod x minus mu. So here it is. If you observe this one, x minus mu is equal to what? Sigma t. So for that we are substituting mod sigma t e power minus what we chosen, x minus mu by sigma is equal to t. So if you substitute in that, what we get? E power minus t square by 2. So minus t square by 2 dx is nothing but what we got it. If you apply derivative for this one, dx is equal, so yes, previous also we saw, we did, dx is nothing but what we got it, sigma dt. Sigma dt. So for that, here it is 1 by sigma into square root of 2 pi. If you observe this one, modulus of sigma. So here it is, standard deviation is nothing but positive square root. Obviously this is positive. So here 1 sigma and here 1 sigma. That is nothing but sigma square, right? So sigma square by sigma integral minus infinity to infinity e power minus t square by 2. So minus t square by 2 dt, right? After substituting the assumptions what we chosen. Here it is 1 sigma and 1 sigma cancel. Then what will get? Sigma by square root of 2 pi. And next if you observe this one, this is a even function, right? E power minus t square by 2. How can we say that this is even? If you substitute in place of t as minus t. So e power minus t whole square by 2. Is there any change in that? No. We'll get it as again e power minus t square by 2. This is as it is we are getting, right? E power minus t square by 2. So for that, by definite integral property, simply what we can write? 2 into integral 0 to infinity e power minus t square by 2 dt. So e power minus t square by 2 dt. So this one we got it. And already we simplified this one. This value is nothing but what we said, root pi by 2. Okay, so that's why here it is. If you observe this one, what we got it, dx is equal to that, and next mod sigma t we substituted sigma square, and next modulus t e power minus t square by 2. This is a even function. So here it is, modulus of t is t. Why? Because here it is integral 0 to infinity. Next, now we have to simplify this one integral. So 2 Here it is 2 sigma by 2 root pi. So 2 we can write as root 2 into root 2, 1 root 2 cancel. So root 2 pi by sigma into this one. And again we are proving this, we are doing that minus t square by t is equal to z. Okay, differentiating on both sides 1 by 2 into the derivative of t square. So the derivative of t square is 2t. And next dt, derivative of this one, which is equal to dz by dz, derivative of z with respect to t. Then 2 cancel, t dt is equal to dz, we got it. And simply if you substitute in that, is there any change in the limits? So this is a definite integral. So if you substitute in place of t as 0, then what we'll get, 0 square by 2 is nothing but again 0. If you substitute infinity, z is equal to infinity. There is no change in that. It means simply what we'll get, square root of 2 by pi sigma integral 0 to infinity e power minus t square by 2 means what we chosen, minus z, and t dt here it is. If you observe this one, t dt, t dt is nothing but what we got it, dz. So dz, so this is equal 2 by square root of 2 by pi into sigma, and apply integration for this, e power minus z integration is e power minus e power minus z between the limits 0 to infinity. And then so square root of 2 by pi sigma, and we can substitute the limits in place of z as infinity minus e power minus infinity, and we are near substituting lower limit, the sign will change, e power minus 0. And then what we'll get, square root of 2 by pi, here it is, into sigma, then e power minus infinity is equal to how much, 0, and e power minus 0 or e power 0 is nothing but 1. So 1 plus 0 is nothing but 1. So finally what we got it, square root of 2 by pi into sigma. So this one simply we can write 4 by 5 times of standard deviation respectively. Simply in other words, we can say that mean deviation about mean for normal distribution is 4 by 5 times of standard deviation respectively. So root 2 by pi approximately you get it as 4 by 5. Okay, so that only simply we wrote here, see, 4 by 5. Hence the mean deviation from the mean for normal distribution is equal to 4 by 5 times of standard deviation approximately. So this is about mean deviation about mean of normal distribution. Next one, characteristics of the normal distribution. Okay, so characteristics, first one, the graph of the normal distribution in xy plane is known as normal curve. So this is the curve we called as a normal curve. This one already we saw in continuous one, continuous distributions. This is nothing but y is equal f of x. This is a curve. Okay, y is equal to f of x is a curve, and this is we called as a bell-shaped curve. So if you see that this is a bell-shaped curve, and this is symmetrical about what? Mean. Symmetrical about mean. And here it is, we will see that standard normal variate, there is nothing but z is equal x minus mu by sigma. So where x is nothing but mean and sigma is nothing but standard deviation, x is a continuous random variable. Okay, so that one we'll see here. So the curve, what is meant by normal curve? A graph of the normal distribution y is equal to f of x in the xy plane. It means a curve which is located in xy plane, which is in the form of this one. That is nothing but bell-shaped curve is known as normal curve. And next one is, here it is, the curve is a well-shaped curve, what we said, and symmetrical with respect to mean. That is about the line x is equal mu. So about x is equal to mu, we are saying the curve is symmetrical. So this is x is equal to mu. Okay, so this is symmetrical about the line. And next, and the two tails on the right and left sides of the mean extends to infinity. It means these are we called as the tails. This one we called as right side, so right tail, and it is having left side, so left tail. And this is extended up to from where to where, minus infinity to plus infinity. top of the bell is directly about the mean. Area under the curve represents the total population. So why? Because next further we'll get as starts population, sample, all those things. This total area. So here it is what we have. This total area represents this total one area represents the total population. And one more important thing, the total area under the curve is 1. Okay, it means we already said this is symmetrical means how much distance from this one to this side, same that much of distance from this one to this one. It means if we are saying the total area under the curve is 1, so it means simply what we can say that here it is 0 0.5 and this side 0 0.5. Okay, so the total area under the curve is 1 and we are dividing into two parts. Okay, why? Because this is a symmetrical, we are saying same 0 0.5 and this side also 0 0.5. Okay, so that only here we discussed. So here it is, the curve represents the total mean population, and already we proved mean, median and mode of the distribution coincide at x is equal to mu as the distribution is symmetrical. So the normal curve is unimodal. So what it represents? Unimodal, bimodal is nothing but, unimodal is nothing but it is having only one maximum point, that is x is equal to mu, or it is having only one mode, then also we can say that unimodal. Bimodal is nothing but it is having two modes. Okay, next, x-axis is asymptote to the curve. So what is meant by asymptote? So asymptote is nothing but, so which is a line and it coincides the tails of that normal curve. Okay, but exactly not touches. We'll say that at infinity if it touches, that is nothing but asymptote to the curve. Okay, so this is the one we said. No, here it is. This is x-axis. So here it is. What we said, the curve, here it is, this is we are saying as x-axis, right? So this x-axis at infinity, it extends to infinity. If you extends to infinity, it may touches that line. Okay, that is simply we are saying as asymptote. X-axis is the asymptote to the curve. So asymptote is nothing but a line. Okay, so this is the line. That line is nothing but here we are saying x-axis. Okay, that x-axis is a line which touches at infinity. Next, linear combination of independent normal variates is also a normal variate. So combination of variables, independent normal variables, obviously normal variate. And next, the points of inflection of the curve at x is equal to mu plus or minus, and the curve changes from concave to convex at x is equal to mu plus sigma to mu minus sigma. So this is we are saying as normal curve, in that this is concave when we are extending that. Okay, so when we are increasing that, mu minus sigma to mu plus sigma, next mu minus 2 sigma to mu plus 2 sigma. Like that when we are extending that, that concave, so that concave is changes to convex. Okay, so it reaches to this one. Okay, it means it will say that flat. Okay, it may approaches that. So that only here we represent, see, this is concave one, so this is concave, and here it is having when we are increasing that, so the curve extended, see here x is equal to mu, at the point see here we'll set x is equal to a and x is equal to b, and next to x is equal mu minus sigma, and next one mu plus sigma. Okay, next to mu minus 2 sigma, and next to mu plus 3 sigma. See here it is, if you observe this one mu minus sigma to mu plus sigma, so the curve is here it is up to this, right? So like this up to here it is k. Now if you extend this one mu minus 2 sigma, it is mu minus 2 sigma mu plus 2 sigma. If you go for mu minus 3 sigma, actually the curve entire curve lies between that mu minus 3 sigma mu plus 3 sigma, it will approaches. Okay, that only there we said. So where actually the it is in concave when it is extended. Okay, so when we are increasing length of that one, so then obviously automatically that concave one of changes to convex. Okay, next, the probability that the normal variate x with mean mu and standard deviation sigma lies between x and x2 is given by. So already we got it, this one in continuous. If it is lies between a and b, simply what we calculated there, P of A less than or equal to X less than or equal to B. Okay, if it is lies between these two, A less than or equal to X less than or equal to B, simply what we calculated, integral A to B f of X dx. This is the one we use, right? So integral A to B f of X dx. Okay, so here it is, same that one in place of here we are saying as x1 and in place of B as x2, and integral A to B, here we are writing in place of A is x1 and in place of B as x2, and f of x dx as this, but this is a normal one, normal distribution. So for that f of x is nothing but simply we are substituting the definition 1 by sigma and square root of 2 by e power minus 1 by 2 x minus mu by sigma whole square dx. Okay, it depends on what? So two parameters, it depends on two parameters. What are those? Mu and sigma. That's why we said in definition also minus infinity to mu less than mu less than infinity and sigma greater than 0. Why? Because here only two parameters. What are the parameters in binomial? So in binomial n and p are parameters, and in Poisson lambda is a parameter, and coming to in continuous, the parameters of a normal distribution are mu and sigma. By increasing, by changing the values, see we do get different normal curves for different values of mu and sigma. Okay, so if you are increase, if you are giving different values, you will get different normal curves. Of course, the entire curve there is no change. Okay, it may be flattened or it may be extended. Okay, so it may be reduced. So but the when we are increasing, it depends on completely the values of mu and sigma, and it is an impact because to plot all such normal curves. Okay, but it is not possible. Why? Because not possible in the sense it takes a time and it is impracticable risk. Okay, task to curve the such type of all those normal curves. Okay, so for that simply what we are doing here, if we are by putting z is equal to x minus mu by sigma, the RHS of equation 1 becomes independent of the two parameters. Here z be known as normal distribution, also say that, or in other words standard variable. So standard variable in it means in different, if you are coming to the problems for taking mu value and sigma value and drawing the curve is nothing but it elaborates, it takes a difficult task by increasing the number of values for putting on a graphic. Okay, so for that simply what we are taking in place of that one, z is equal x minus mu by sigma. By knowing the value of mu as well as sigma, if it is lies between the values, if it is more than that, if it is less than that, what we have to choose. Okay, so based on that we'll calculate it. Okay, so directly it's a risk process. It takes a time, the time taking process. For avoiding that, we are using this one, the change of scale. We can say that z is equal x minus mu by sigma. Here z is known as standard variable, and area under the curve is distributed as follows. So already we said the total area under the curve is 1. Okay, how we distributed that curve? So what we said, mu minus sigma, mu plus sigma. Okay, mu minus 2 sigma to mu plus 2 sigma, mu minus 3 sigma to mu plus 3 sigma. Already we said the most probably the entire normal curve lies between mu minus 3 sigma to mu plus 3 sigma. How much it is? 99.73% area occupies. Only for mu minus sigma to mu plus sigma. So mu minus sigma to mu plus sigma, how much? 68.27%. Suppose mu minus 2 sigma to mu plus 2 sigma. Keep in mind these values also. Mu minus 2 sigma to mu plus 2 sigma, how much area occupied? 95.43%. And mu minus 3 sigma to maximum 1, but we can't measure that. Suppose that this is a my extended one. Suppose that 99.73 percentage. Okay, so these are the values, and now therefore the area of normal curve between, so simply what we mentioned in a graph, that one we are writing. So area of a normal curve between mu minus sigma and mu plus sigma is 68 point, and the area normal between mu minus 2 sigma to mu plus 2 sigma, and next mu minus 3 sigma to mu plus 3 sigma is 99.73%. Next, standard normal distribution. So when we say that that is a standard normal distribution, if the mean normal distribution with the mean mu is 0, so keep in mind, so mu is equal to 0. It means mean mu is equal to 0 and standard deviation is 1. So sigma is equal to 1. Then we call that is nothing but standard normal distribution. Okay, so attain more, and it means what we'll get. So we know that z is equal to what we chosen, x minus mu by sigma. So x minus mu by sigma. Then z is equal to what? X minus mu is nothing but what we said, 0. So x minus 0 by sigma. Sigma is nothing but how much we chosen, 1. Then what we'll get, z is equal to x minus 0 is nothing but x by 1 is nothing but x1. So x is equal to how much? X is equal z. Okay, so for that, if we are drawing the curve, here it is at a specific point, here it is x is equal to mu we are saying, then z is equal to 0. So here it is x is equal to mu, then what about we'll write z is equal to 0. If it is x is equal to some z, some value 35, 45 like that, and z1 we have to calculate by taking up x minus mu by sigma. So that only here we wrote here. So the random variable that follows this distribution is denoted by z. So standard normal this one denoted by z. If a variable x follows normal distribution with the mean mu and standard deviation sigma, the variable z is defined by, okay, as standard normal distribution where it is, if mean value is 0 and standard deviation is 1. So the standard normal distribution is also known as unit normal distribution, or simply we called as Z distribution. The standard normal distribution is also known as unit normal distribution or Z distribution. And next one, probability density of normal curve. Okay, so these are the formulas we may use for calculating that. So by using the range of scale, z is equal to x minus mu by sigma. So here it is the probability that the normal variate x with mean mu and standard deviation sigma lies between two specific values x1 and x2. Okay, so this is the first one. If the lies, if it is x lies between x1 and x2, so it means p of x1 less than or equal to x less than or equal to x2. It means this one we are going to calculate. P of x1 is less than or equal to x less than or equal to x2, like this. If x is lies between, like as suppose if you are taking a curve, so here it is we are saying x, so this is x is equal to mu, right? So x is equal to mu, and next to x1 we are saying and x2 we are saying. If the area lies between these two, okay, x1 and x2, then what we have to calculate, so that one we are going to see. So x1 and x2, with x1 less than or equal to x2, so it means first one should be less than or equal to second one. Can be obtained using area under the standard normal curve as follows. Okay, so what is about that? Perform the change of scale. So first we need to write this one, z is equal to x minus mu by sigma. So this is called as standard normal period change of scale, z is equal to x minus mu by sigma. And by taking the values of x1 and x2, we need to calculate z1 and z2. Same like this. So if you know that x1, simply we calculate z1 is equal to x1 minus mu by sigma. If it is x2, simply we write z2 x2 minus mu by sigma. Then the values of x1 and x2 respectively. It means by taking an x1 and x2, we'll calculate z1 and z2. But you may get positive one, or you may get negative one, or you may get one is positive, another one is negative, right? So these many of possibilities may arise in that case, right? So first one may get positive, second one may get positive, third one next, first one may get negative, second one may get negative, and first one may get positive or second one may get negative. So in that case, suppose that we are seeing the cases if both Z1 and Z2 are positive or both negative. It means after finding Z1 and Z2, if you are getting both are negative values or if you are getting both are positive values, then we have to use that formula is area of Z2 minus area of Z1. Okay, P of x1 less than or equal to x less than or equal to x2 is nothing but area of Z2 minus area of Z1. Here it is Z1 and Z2 both are positive or both are negative. So this side you can draw that or this side also you can draw that. Why? Because this is a symmetrical one. So both same here it is. So for that you can draw the curve here it is. So both Z1 and Z2 are positive. Suppose both are positive. Then here we choose a positive side. Okay. If it is both are negative, so simply here you can write Z1 and Z2. Okay, between this area of Z2 minus area of Z1. Okay, so this is the area we are calculating. Okay, so this is case 1 when it is both are positive or both are negative. Next, if it is one is less than 0, first one less than 0 and the other one is greater than 0. Okay, in that case we can use area of Z1 plus area of Z2, any one of that. So not only this Z1 less than 0 and Z2 greater than 0. So here it is area of Z2 plus area of Z1. Suppose if you get Z1 is greater than 0 and Z2 is less than 0, then if nothing in that, it means suppose we calculated, suppose x1 I gave 4 and next x2 I gave 5. Okay, and then you need to find z1. Of course mu value we need to know that 4 minus mu by sigma, and next you calculated z2. So z2 is equal to 5 minus mu by sigma. So this one we calculated. Okay, after calculating, if you are getting both are positive or both are negative, so in that case we can take the above one, area of z2 minus area of z1 modulus, and areas always must be positive one. Okay, even if you get negative, there it is modulus they give, that's why. Okay, and here it is less than 0 greater than 0, so area of z2 plus area of z1. So here it is, this is the value we are writing, but area of this one is nothing but we can't calculate it. So we can calculate, but it takes a time to find the area of that one. So for that we have normal distribution table. By using that normal distribution table, we write the values of this one. Okay, so we are calculating only of z2 value and z1 value, but what we require the area. Okay, so how much area is occupied if x is lies between x1 and x2. Okay, so by adding area of z2 plus area of z1, we get the entire area of this one. Okay, so for that we use normal distribution table for getting that. Okay, next next case, these are the two cases when it is, this is step 1. So when it is, this is, you need to remember that to find p of x1 less than or equal to x2 less than or equal to x is equal p of z1 less than or equal to z less than or equal to z2. Okay, so if it is both are positive, case 1 you need to use, both are negative, second case we will use. Okay, next next one, here it is step 2, p of z greater than z1. So it means suppose they asked to find only p of x greater than x1. So like as we find at least at most two dimension, then we may use p of x greater than or equal to 2. Okay, so immediately what you need to do that, you have to take 2, put x is equal to 2, then you need to find z1. Okay, z1 is equal to x1 minus mu by sigma. Here x1 is nothing but 2. So you need to substitute and then we have to find. Here also you may get less than 0 or greater than 0, right? So less than 0 may get or greater than 0 may get. If it is greater than 0, z1 is greater than 0. So here it is z1 we are saying. So greater than 0 we are saying. So more than that is nothing but this one. So the total area, this is nothing but 0.5, and this is also 0.5. But what we require, this area we require from here to there we require, but we don't know this is up to infinity. So for that simply what we are taking, here it is 0.5 minus area of z1. Okay, so this one we are taking and then we are have to use this one, p of z greater than z1 is equal 0.5 minus area of z1. Okay, next If it is less than 0, so if p of z1 is less than 0, then 0 point p of z greater than z1 is equal to 0.5 plus area of z1. Okay. Next, that is for step 2. Step 2 A, B, C, and we are taking. So in that C, if it is p of z less than z1, then we can write. We already know that the total probability is 1. So by using that 1 minus p of z greater than z1. In that case also we may get greater than 0 one case and less than 0 another case. So 1 minus p of z greater than z1. If z greater than z1 and z1 greater than 0, this is what? 0.5 minus area of z1. So that one here we substitute. 0.5 minus area of z1 we substituted. After simplifying this, so are you getting that one or not? 1 minus 0.5, and we are multiplying minus inside of the terms. So 1 minus 0.5, and next minus to minus plus area of z1, right? So here it is 1 minus 0.5 is nothing but 0.5 plus area of z. So that's why here we go. And the shape of the curve is, in that case we are giving as, here it is 0.5 plus, this is 0.5 plus area of z. Okay. Next, if z1 is less than 0, so it's same. Here it is z1 less than 0, 0.5 plus area of z1. So that one we substituted. So 0.5 minus area of z1. So that one we wrote here. Okay, this is the shape of the curve. So these are the formulas we use. We are solving the problems if they are asked to find probabilities for that. And next, applications of the normal distribution. So what about the what importance we are using for normal distribution? Okay, where we use this applications. Okay, it plays a very important role in statistical theory because of the following reasons. First one, data obtained from psychological, physical, and biological measurements approximately follow normal distribution. Okay, so not only in one way, so physically, next biologically. Okay, so biological pharmaceuticals, we use this in psychological way. So in all those cases, we use normal distribution. So like as IQ scores, heights and weights of individuals, etc. So this is all we can say that, okay, we can use normal distribution. And next, most of the distributions that are encountered in practice. So most of the distributions we may get by using this distribution, like as binomial, Poisson, hypergeometric. It means discrete distributions will get by using normal distributions approximately. And next, if the number of trials is independently large and neither P nor Q is very small, then binomial distribution tends to normal distribution. So neither P nor Q is very small. So it means both the cases. Okay. So very large case, N is indefinitely large. Then binomial distribution tends to normal distribution. Okay. If the parameter lambda tends to infinity, then the Poisson distribution tends to normal distribution. Why? Because in binomial distribution the parameters are n and p, and in normal Poisson distribution the parameter is lambda. So here are what we are saying: when n is approaches to infinity and p is very small, in that case that binomial distribution tends to normal distribution. But in Poisson distribution, lambda is a parameter. Suppose that when lambda is approaches to infinity, then the Poisson distribution tends to normal distribution. Next is a limiting case of binomial distribution for large numbers. What we discussed then, when n is very large, indefinitely large. In that case, we that is approaches to normal distribution, and this is applied problems in kinetic theory of gases and fluctuations in the magnitude of an electric current. In physical, also we said physically also we use normal distributions, where we use in kinetic theory of gases and magnitude of an electric current. And next, even if a variable is normally distributed, it can sometimes be brought to normal form by simple transformation of the variable. So by using this normally distributed, then we can convert it to normal form, and then easily we can say, simplify. And next we will get it in testing of hypothesis. There also some statistics also we use this, that only for large samples any statistic. that is sample mean, sample standard deviation, all are approximated by normal distribution, and it can be studied with the help of normal curve. All these things we represent by normal curve. It's easy to find confidence limits of the population parameters. Population parameters are nothing but mean, variance, standard deviation, population parameter, population mean, population variance, population standard deviation. So these things, population, sample, all these things will get as in 15 minutes. Okay. So population is nothing but simply will say that totality of observations overall universe. We can say that. That is population. Sample is nothing but just what we are gathering samples. Like as simply boiling rice is a population, in that what we are collecting for checking some pieces, that is sample. Okay. So the normal curve is used to find confidence limits. So confidence limits is nothing but how much confidently we are saying. Suppose if you write an exam, simply people say that okay, I'm confident 90%, I may get 70 to 90. Okay, like that only here confidence interval will get. That one also in statistics we use. Next, the proof of all the tests of significance. That only we said significance, test of significance is nothing but testing of hypothesis. So that one also fundamental assumption that the population from which the samples have been drawn is normal. So there we assumption will take, samples will take directly, right? That samples we came from population, which is from fundamental assumption is normal curve. And one more thing, normal distribution finds large applications in statistical quality control. So in QC, okay, if you go for pharma, there it is having quality control. Okay, so in that quality controls also we use this normal distribution for controlling the limits. It means range. Okay, so only this liquid or this medicine has to prepare only this much to this much range has to be. So all these things we use for normal distributions. Okay. And next, so these are the values we use. What we said no. So here it is from area under standard normal curve from 0 to this one. Here we use these values. Okay. So these values we use for writing them. So area of 0 0.1, 0 0.2. Suppose here it is, we need to calculate, we need to write the value of area of, suppose here we can write area of 0.567. Then simply we'll write it as, we'll see that first this one first part 0 0.5, we'll see that, and next remaining 0 0.06. Here it is, if you observe this one, this is 0 0.06. Here it is. So this one will see that which value will take, area of this one is nothing but this is the value. So like this 0 0.6 and this is 0 0.5, 0 0.06, 0 0.5. In the same way, if you are taking 0 0.0, suppose 0 0.8, so here it is, we are writing as area of 0 0.8. So area of 0 0.8 is nothing but 0 0.8, 0 0.00. Only this is the value. Yeah. So like this you need to see that. First after decimal first value here it is, and second digit we need to see here. Okay. So here and this one. Okay. So these things we need to see for writing tabular values. Okay. So let us see that problems on Poisson normal distribution. Here it is. First one. See that if x is a normal variate with the mean 30 and standard deviation 5, find the probabilities that 26 less than or equal to x less than or equal to 40, x greater than or equal to 45, and minus 1.43 less than or equal to x less than or equal to 6.19. Here if you observe that clearly, so x is a which variable? Normal variable. And what they gave in the problem? Mean they gave. So mean is nothing but what? Mu. So mu is equal to 30 they gave. And next, standard deviation also they gave. Standard deviation we are giving as sigma. So sigma is equal to how much they give? 5. Find the probabilities. Okay, probabilities that P probability is nothing but we are representing P. And first problem what they ask, 26 less than or equal to x less than or equal to 40. So this is first question they asked. In the same way, second question what they asked, P of x greater than or equal to 45. So P of x greater than or equal to 45. And next, third question, P of minus 1.3 less than or equal to x less than or equal to 6.19. So see here that only we wrote what they gave the information in the problem first we wrote. Immediately you need to write the change of scale here normal then xz is equal to x minus mu by sigma. Okay, so this is step 2 first A. Then in that we need to check case 1 or case 2. So this is x1 we are saying, this is x1 and this is x2, right? So for that first we need to calculate z1. So z1 is equal to x1 is nothing but what? 26 minus mu is nothing but how much? 30 by standard deviation is 40. Sorry, standard deviation is 5. So 26 minus 30 is nothing but minus 4 by 5. So we may get it as minus 0.8. So this is Z1. In the same way Z2. So Z2 is equal, same like as 40 minus 30, 10 by 5. So 10 by 5 is nothing but 2. So it means we need to, one is negative and another one is positive. Okay, so now we need to calculate that. See here, p of that one only we calculate minus 0.8 this one. In that case, so p of z1 less than or equal to z less than or equal to z2, right? So one is negative, another one is positive. In that case, what we set the formula, area of z2 plus area of z1. Now area of 2 plus area of minus 0.8. So here it is a symmetrical one. Normal curve is a symmetrical one. So area always must be positive. So if you write simply, if you get negative also simply we write area of 2 plus area of 0.8. Due to symmetry we'll say that. Now these are the values we need to write from the normal distribution. Keep in mind here 2 we got it, right? So for that, see in normal distribution table. So 2 is nothing but what? 2.0. And in the new above one also 0.00, right? So 2 point area of 2 is nothing but what is the value here? It is 0.4772. And another one, what we got it? 0.8, right? So 0.8 is nothing but where it is? This one. 0.8. How much? 0.2881, right? 0.8 here it is. This is 0.2881 and 2 0.49477. Okay, so these values we need to substitute there. So if you substitute that one or not, see. So here it is. See here, 0.4772 plus 0.2881, same values. Okay, and now by adding those two we'll get the area of that one. So here it is 0.765. Okay, so this is first one. Okay, next in the same simply only one thing we wrote for first we calculated, we substituted the formula and immediately by table values we got. Okay, tables also allowed for the examination. And second one, p of x greater than or equal to 45, same like as this 45 minus 33 we got it. And the formula we are using, z1 is greater than 0. So if it is z1 greater than 0, what we said in step 2b. So here it is. Here it is step 2b. These formulas you need to remember. So z1, this is z greater than z1. So in that z1 greater than 0, what is the formula? Here it is 0.5 minus area of z1. So that one we applied here. It is see 0.5 minus area of z1. This one. So the area of z1, z1 is how much? 3. And this is the tabular value, area of 3, how much it is? See, 0.4987. So this is 0.4987. So some of the textbooks there are 65, so 87. And this one. Next, third one, same like as first one. X is equal to minus 1.43. What we got it? Minus value. And next, z by x is equal to 6.15. Okay, there is we got 6.19, we got it as 1.73. Now 0.81 minus this one, then area of Z2 plus area of Z1, area of 1.73 plus area of minus 0.81. So now see the values 1.73 and 0.81. So 1.73, 0.81. See how to see this one. So here it is in row wise 3, 4 like this 1.73. So it means here it is 1.7, right? And next 3. So 3 is nothing but this is the one. So where it is 1.7, this one, and 3 is nothing but 0, 1, 2, 3. This is the value, right? 0.458, 1.73 like this. So 1.7 here and column wise 0.03. Okay, 0.458. This value we need to substitute. And next one 0.81. Suppose. So 0.8 is this one and 1 is nothing but 0.2910. So those values we need to substitute here. Those things we substituted are not. See for 0.4582, 0.4582, 0.2910, right? So by adding that we get 0.7492. Okay, so like this simply you need to know that what about x they give and substitution. After that areas you need to write, formulas you need to remember. So if it is less than 0, if it is greater than 0, if it is between. Okay, so all those things you need to remember that. Okay, next one.